Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter System of Particles and Rotational Motion. If you have any doubts regarding any question or its solution, then please write us in the comments section. And if you feel that you have more difficulty in any of the chapters of physics, then also please mention the name of that chapter in the comments section so that we can give more priority on it and solve more and more questions on that chapter. Also, the homeworks on every chapter will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. Okay, so we shall start off with the first question. So it is told that the moment of inertia of a circular ring of radius r and mass m about diameter is, okay, moment of inertia of a circular ring which is having radius r and mass m about its diameter. So here we can apply the uh, perpendicular axis theorem. So we can say that this I and this is also I. So we can say that so Ix plus Iy equals to Iz, we can say. So the moment of inertia about the axis of the ring, we know that is given as mr square. So we know that, so therefore mr square is equal to 2I. So I will be equal to mr square by 2. mr square by 2. So option C is the correct answer. So in any of the steps of the solution, if you are unable to understand, or in the questions also any doubts if you are having, then please write us in the comment section. Then it is told a door 1.6 meter wide, a door is there which is 1.6 meter wide, requires a force of 1 Newton to be applied at the free end. 1 Newton force we have to apply at the free end to open or close it. So it is being hinged at this, at one end. The force that is required at a point 0.4 meter distant from the hinges from opening or closing the door is, so the torque required to open the door, open or close the door, will be the same. The torque or the moment of force, required, that will be the same. So we can say that R1 into F1, that will be equal to R2 into F2. So therefore R1 is 1.6 meter, and then the force required is 1 Newton, and that is equal to R2, which is 0.4 meter, and that F2 we have to find it. So therefore meter and meter will cancel. So F2 will be equal to 1.6 by 0.4 Newton. So it is 4 4 is 16. So 4 Newton is required. Option D is the correct answer. Then the question number 3 has been told that the moment of inertia of a circular disk of radius 2 meters. The radius of the circular disk is 2 meters and the mass is 1 kg, and we have to find the moment of inertia of this disk. The moment of inertia of this disk we have to find about an axis passing through the center okay. about an axis passing the center of mass but perpendicular to the plane of the disk is 2 kg meter square. So I moment of inertia about the axis of the disk, that is 2 kg meter square. Its moment of inertia about an axis parallel to this axis but passing through the edge of the disk. It means along x1 y1. It means that Ixy, that is given as 2 kg meter square. So Ix1 y1, that we have to find. So here we have to apply the parallel axis theorem. Parallel axis theorem we have to apply. So that is Ix1 y1, that is equal to Ixy plus mr square, that is md square. So the distance in between these two axes we have to find, that is r. So plus mr square. So that will be 2 plus mr square, that is 1 into 2 square. So that will be 2 plus 4, that is 6 kg meter square. Option D is the correct answer. Then it is told that a solid sphere of mass m rolls down an inclined plane without slipping. A solid sphere is there which it rolls down an inclined plane. It rolls down the inclined plane without slipping, starting from rest at the top, u equal to 0. Initial velocity is 0. It starts from rest. Then the linear speed of the sphere at the bottom of the inclined plane, when it reaches the bottom of the incline, its linear speed is v. The kinetic energy of the sphere at the bottom is, okay, so there is no slipping. It means that we can say that v equals to r omega. V equals to r omega, where omega is the angular velocity. So we know that the total kinetic energy equals to the translational kinetic energy, that is half mv square, plus rotational kinetic energy, which is half I omega square. So the moment of inertia of the sphere, is given as 2 by 5 mr square. 2 by 5 mr square. So therefore this will be, and v equal to r omega, that's why you will say half mv square plus half into 2 by 5 mr square into omega square. So r square omega square is v square. So this will be equal to half mv square plus half into 2 by 5 mv square. So we can say it is half mv square, I can take as common, and then I can say 1 plus 2 by 5, which is 7 by 5. 5 ones are 5. Okay, so 7 by 5 into 1 by 2, that is 7 by 10 mv square. So 7 by 10 mv square is the required kinetic energy of the sphere when it reaches the bottom of the inclined plane. So option D is the correct answer. Then it is told a force F vector, which is 5 I cap minus 2 plus 2j cap minus 5k cap, acts on a particle whose position vector is r vector, which is I cap minus 2j cap plus k cap. What is the torque about the origin? So the torque about the origin that we have to find, that is r cross f. So we have to find r cross f, means we have to find the determinant of ijk, and first I should write the components of r vector, that is 1, minus 2 and 1, and then the components of force vector, that is f2, that is 5, 2 and minus 5, then plus, minus, plus. We have to expand this determinant, we have to expand this determinant, we have to expand. So that will be I cap into 10 minus 2 minus j cap into minus 5 minus 5, then plus k cap into 2 minus of minus 10, that is plus 10. So this will be 8 I cap, then plus 10 j cap plus 12 k cap. This is r cross f. So this is the required torque about the origin. So option B is the correct answer. Then it is told a rotating wheel changes its angular speed from 1800 rpm to 3000 rpm in 20 seconds. So this is the omega initial, this is the omega final. This is the angular speed has changed in time t equal to 20 seconds. What is the angular acceleration? Assuming it to be uniform. So when the angular acceleration alpha is uniform, it means it is constant, then we can say that the final angular velocity, that is equal to omega initial angular velocity plus alpha t. Since we know that v equal to u plus at, so similarly it will be omega f equal to omega I plus alpha t. So therefore alpha will be omega final minus omega initial by t. So this will be omega final is 3000 rpm. So we have to convert it into radian per second. So 1 rpm means 1 rotation per minute. So 1 rotation means 2 pi radian divided by per minute. rpm means rotations or revolutions per minute. So 1 minute is 60 seconds. So I can say it is pi by 30 radian per second. So 1 rpm is pi by 30 radian per second. So therefore omega initial can be written as 1800 into pi by 30 radian per second. So this will be 0 0 will cancel, 3 6 18. So this is 60 pi radian per second. Then omega final, that will be equal to 3000 into pi by 30, that will be this much radian per second. So that will be equal to 0 0 will cancel, then 100, this will be 100 pi radian per second. So therefore we have to find alpha will be omega final minus omega initial by t. So that will be omega final, which is 100 pi minus 60 pi divided by t, which is 20. So this much radian per second square. So this will be 40 pi by 20, that is 2 pi. So 2 pi radian per second square. This is the angular acceleration. So option A is the correct answer. Then here it is told that a body having a moment of inertia about its axis of rotation, a body is there which is having its moment of, so it can be having any shape it can have, any irregular shape also. It is having a moment of inertia about its axis of rotation, we can say it as I naught, that is equal to 3 kg meter square, is rotating with angular velocity, it is rotating with an angular velocity omega is 3 radian per second. Kinetic energy of this rotating body is same as that of a body of mass 25 kg moving with velocity v. So another body is there which is having only translational motion, which is moving with a velocity v, and its mass is m1, which is 27 kg. So it will have the same kinetic energy as this rotating body. So therefore kinetic energy of this the given rotating body, that is equal to the kinetic energy of this translating body. So it means that this half I naught, so you can simply say I, so half I omega square, that is equal to half m1 v square. So therefore, so half and half will cancel, we need to find out this v actually. So v square will be equal to I omega square by m1. So that will be I is 3 kg meters square, and omega is 3, so 3 square divided by m, which is m1, which is 27. So 3 nines are 27, 27, 27 will cancel, so v square equal to 1, so v is equal to 1 meter per second. So it means that the translating body should have a velocity of 1 meter per second, then only its translational kinetic energy will be same as the rotational kinetic energy of this rotating body. So option B is the correct answer. So in any of the solution steps, if you are unable to understand or any other doubts you are having, then please write us in the comment section. Then question number 8 is that the moment of inertia of a thin uniform rod. Moment of inertia of a thin uniform rod. Moment of inertia. Okay, so thin uniform rod is there. Its moment of inertia, which is rotating about the perpendicular axis passing through its center. Rotating about its perpendicular axis passing through its center is I. So I, okay. And then if the same rod is bent into a ring and its moment of inertia about its diameter is I dash, it means that if this rod is bent into a ring, this rod is bent into a ring shape, then about the diameter of the ring, the moment of inertia is I dash, then the ratio of I and I dash is how much? Okay, so we know that I will be equal to ml square by 12, ml square by 12, where L is the length of the rod. So how to find out this ml square by 12? This will be mx square so moment of inertia, it will be integral x square dm, from it will go from minus L by 2 to plus L by 2. Now dm, that we can say this is equal to lambda into dx, where lambda is mass per unit length. So this will be m by L into integral x square dx from minus L by 2 to L by 2. So this will be ml into x cube by 3. So this will be 1 by 3 into x cube. So this will be L cube by 8 minus of minus L cube by 8. This will be plus L cube by 8. So this is L cube by 4. So this will be ml square by 12. So this will be, so now when this has been bent into a ring, then the radius of the ring we have to find. Then I dash will be actually mr square by 2, mr square by 2. It is the moment of inertia along the diameter of the ring. Moment of inertia along the diameter of the ring. That will be mr square by 2. Now the radius of the ring, how to find? How to find the radius of this ring? Now, so 2 pi r, the circumference of the ring, that is same as the length of the rod. Since the rod is only bent into the ring, so its length will be same as the length of the ring. So 2 pi r is equal to L. R will be equal to L by 2 pi. Now therefore I dash will be equal to half m. Mass will remain the same, so we should keep it as m only. So m into L, half m into L by 2 pi whole square. So this is ml square by, so this is 4 to the 8 pi. So therefore I by I dash, so this is I, and so I by I dash, that will be ml square by 12 divided by ml square by 8 pi. So ml square will cancel. This will be 8 pi by 12. Sorry, this is pi square. So 8 pi square by 12. 4 to the 8. Okay. So 4 2 is 8, 4 3 is 12. So this is 2 pi square by 3. So option D is the correct answer. Then it is told which of the points is likely the position of the center of mass of the system shown in the figure. So here we have air, here we have sand. So we know that sand is more heavier. Sand is heavier than air. Sand is heavier than air. So the center of mass of the system will lie and there okay, here you can see that the density of sand is heavier. The density of sand is more than the density of air. So, and here the volume of the sand is, but here the volume of the sand is same as the volume of the air present in this region. Since why we know that the area of this triangle will be same as the area of this triangle. So their area is same. It means that we can say the volume which is volume of the region which is occupied by sand, that is same as the volume of the region which is occupied by air. Now density of sand is more than density of air. So it means volume into density, which is the mass of the sand present in the given region, is greater than the mass of the air which is present here. Therefore, we know that since sand is heavier than air, so the center of mass will lie more towards the sand, more towards the sand region, more towards the sand region. It means that the point D is likely the center of mass of the system. It means that option B is the correct answer. Then three bodies, a ring, a solid cylinder, a solid sphere having same mass and same radius, roll down the inclined plane without slipping. They start from rest. If VR, VC and VS are velocities of respective bodies on reaching the bottom of the plane, then so now three bodies are there. One is ring, solid cylinder and a solid sphere having the same mass and the same radius. So radius and masses are same. They start from rest. VR, VM, VC and VS are the velocities of respective bodies on reaching the bottom of the inclined plane. When they will reach the bottom, then the velocity, whose velocity will be the highest, means what is the order of VR, VC and VS, that we have to find. So now we know that final velocity VR, final velocity V, that will be equal to U plus AT. So they start from rest, it means U equal to 0, U plus AT, that will be, the acceleration is constant. Now, so they are not slipping, it means that A is equal to R alpha, we can say that A equal to R alpha, where alpha is the angular acceleration, so they are moving downwards with acceleration A, and friction is also acting upwards, and this is mg sine theta, where theta is the angle of the inclined plane. So friction, so we can say that mg sine theta minus Fr friction, that is equal to Ma. So now A is equal to R alpha. Now the friction will provide, so if we write the moment of force about the center of mass, then we can say that friction will be equal to I alpha. Fr will be equal to the Fr into R, that will be the torque. Fr into r, that will be the torque. So Fr, that will be equal to I alpha by r. So A equal to r alpha means alpha equal to A by r. So I can say it is IA by r square. So friction. So therefore mg sine theta plus, so mg sine theta, that will be equal to Fr plus Ma. So that we can say though, so mg sine theta, that is equal to Ma m plus I by r square into A. So therefore the acceleration, that is mg sine theta divided by m plus I by r square. This is coming. So therefore here initial velocity is 0 only. So v equal to at. But okay, so v square to u square plus 2as. Okay, so the displacement for all of them will be the same, that is s. Displacement is s only, therefore u is 0, so I can say v will be equal to root over 2as. So it means what? It means therefore we can say that the final velocity, that is proportional to root over a. Means that final, which says that final velocity of the bodies, final velocity of the bodies at the bottom of the inclined plane, at the bottom of the inclined plane, is directly proportional to the square root of the acceleration, square root of the acceleration of the body, square root of acceleration of the body. So now the acceleration we got, that is equal to mg sine theta divided by m plus I by r square. So now it means that if the acceleration is higher, it means if the acceleration is higher, then the velocity will be higher. Now moment of inertia of the solid sphere, that will be equal to 2 by 5 mr square. It means that I by r square for the sphere, I by r square for the sphere, that will be, so all these m and theta all will be the same. This whole thing will be the same. So only difference will be in the I by r square. So I by r square will be 2 by 5, which is 0.4. And for the cylinder, the moment of inertia of the cylinder, that is given as mr square by 2, solid, for solid cylinder. So that is, so therefore I of the, so I by r square for the cylinder, that will be equal to m, that is equal to, okay, so I of sphere, that is 2 by 5 mr square, that is 2 by 5 into m, so that is 0.4 m. And I by r square for the cylinder, that is so that is m by 2, that is equal to 0.5 m. And moment of inertia of the ring, that is equal to mr square, simply you know. So therefore I by r square for the ring, that will be equal to m, which is simply 1 into m. So therefore here we can see that if I by r square, the value of I by r square is higher, I by r square is higher, then m plus I by r square is higher. Then 1 by m plus I by r square will be lower. So it means that acceleration will be lower. So it means that if the I by r square is higher, then I by r square is higher than the, sorry, if the value of this I by r square is higher, then the acceleration is lower, and then the final velocity at reaching the bottom of the inclined plane, that will be also lower. So I by r square is the least for the sphere, and it is highest for the ring. So therefore the velocity of the sphere, that will be the least on reaching the bottom of the plane, and the velocity of the, okay, so I by r square is the highest. Okay, I by r square is the highest for the ring, so the acceleration of the ring will be the least. Acceleration of the ring will be the least, and then the acceleration of the cylinder, and then the acceleration of the sphere. So acceleration of the sphere will be the highest. So it means that velocity of the ring will be the least, and velocity of the cylinder, and then the velocity of the sphere. So since I by r square for the sphere is the least, so the acceleration will be the highest. Acceleration for the sphere will be the highest. So it means that the final velocity of the sphere also will be the highest. So Vr less than Vc is less than Vs. So option C is the correct answer. Then here it is told that two balls are thrown simultaneously in air. The acceleration of the center of mass of the two balls when in air. Two balls are thrown simultaneously in air. Okay. So one ball is thrown like this and another ball is thrown like this. Two balls are thrown simultaneously in air. The acceleration of the center of mass when the two balls when in air. Okay. So when they are in air, their center of mass also are in air only, simultaneously in air. So the center of mass also will be in the air only. So acceleration of the center of mass, we know acceleration of the center of mass, that is equal to m1a1 plus m2a2 by m1 plus m2, where the acceleration of the first part is a1, acceleration of the second mass is a2, then the acceleration of the center of mass of m1 and m2, that is given by this formula. We can write it in the vector form also. So now we know that acceleration of the first ball will be equal to the acceleration of the second ball, which is equal to g minus j cap, which is vertically downwards. We take it as minus j cap. So a1 equal to a2. So therefore acceleration of the center of mass also will be equal to, you can say m1 g vector. Let's say we call it as vector a. Okay. So this will be a vector plus m2 into a vector divided by m1 plus m2. So from here a1, a and a I can take as common. So this will be a vector into m1 plus m2 by m1 plus m2. So that will be equal to a vector only. So it means acceleration of the center of mass also will be equal to g minus j cap. So g will only act. So it means the acceleration of the center of mass of the two balls which are thrown simultaneously in the air will be equal to g. So option A is the correct answer. So in any of the steps of the solution, if you're unable to understand or any other doubts you are having, then please write us in the comment section. We shall clarify them in the subsequent live classes. Then it is told the moment of inertia of a body about two perpendicular axes in the plane lamina. Okay, one plane laminar object we are having, plane laminar object. It means the thickness should be uniform throughout. So the moment of inertia of a body about two axes are these. So let's say about this axis x, that is ix, that is equal to 20 kg meter square, and let's say okay, about two perpendicular axes, it means we have this axis, that is iy. So about this axis the moment of inertia is 25 kg meter square. Then its moment of inertia, okay. Okay, moment of inertia of a body about two perpendicular axes in the plane lamina. Okay, in the plane lamina. So these two axes are in the planar lamina only. Sorry, this is there is something wrong here. So Ix, that is equal to 20 kg meter square. Then its moment of inertia about an axis perpendicular to the plane of the lamina and passing through the point of intersection of x and y axis. It means about z axis. So z axis is suppose perpendicular to the plane of this laminar object. So that we have to find. So here actually we have to apply the, we need to apply the perpendicular axis theorem. We apply the perpendicular axis theorem for moment of inertia. So that is, we have to tell Iz will be equal to Ix plus Iy. So therefore Iz, that will be equal to Ix, which is 25 plus 20 kg meter square. So therefore it is 45 kg meter square. So option B is the correct answer. Then it is told two particles which are initially at rest move towards each other and under the action of their mutual attraction. Okay, so two particles are there, one is m1, one is m2. So they are initially kept at rest, u1 equal to 0, u2 also equal to 0, and they move towards each other due to their mutual gravitational force, due to their mutual gravitational attraction. If their speeds are v and v and 2v at some instant, suppose they come here, there its speed is v and its speed is 2v, then the speed of the center of mass of the system is, so they, so since no so since they are initially at rest, since they are here, the thing is that since they are initially at rest, this is u equal to 0, so the initial velocity of the center of mass of the system, that will be 0 also. So now since there is no external force on this system, there is no external force on the system, there is no external force acting on the system, acting on the system of two objects, acting on this system of two particles, and only their mutual attraction is acting. It means that, and only the mutual attraction is acting, mutual attractive force is acting. It means that there is, so this mutual attractive force, it is only the internal force in the system. So the internal force will not cause any acceleration of the center of mass. So therefore the acceleration of the center of mass should be 0, since the net force on the system, that is equal to 0. So since acceleration of the center of mass is 0, it means that final velocity of the center of mass, or the velocity of the center of mass, will remain constant, it will not change. So since initially it was, since initially the system of since initially the system was at rest, it means that the center of mass was initially at rest. So finally also, so the velocity of the center of mass at any instant will be 0 only, at any instant will be 0. It means option D is the correct answer. Then here it is told a particle is moving uniformly along a straight line as shown in the figure. So this is the path in which that particle is moving. This is point B, this is the point A, this is the y-axis, and this is the x-axis. So a particle is moving uniformly along a straight line as shown. Now during the motion of the particle from A to B, the angular momentum of the particle about the point O, that is how much? So that is, so angular momentum How to find? So L, that is equal to R perpendicular into P, or L vector equals to R vector cross P, R cross P. So it means that the magnitude of L, that is equal to RP sine theta, actually means R sine theta into P. It means that we have to take the perpendicular distance from that point to the P vector, that is R perpendicular, into the magnitude of the momentum, that is P. So it is told that the particle is moving uniformly. It means that V is constant. V is constant and the mass will also remain constant. So therefore that is R perpendicular into MV. Now MV is constant. Now R perpendicular, we have to find that the angular momentum about the point O. So now this perpendicular distance, that is also remaining constant only. That is also not changing. R is changing, but R sine theta is not changing. R perpendicular is not changing. So therefore the angular momentum, momentum of the particle about the point O remains constant. Since why? Since R perpendicular, which is the perpendicular distance, R perpendicular is what? It is the perpendicular distance of the P vector, or you can say V vector, from the point O, from the point O. So that remains constant. So therefore R perpendicular also will remain constant only. So option A is the correct answer. Okay, so here we shall solve the last question of this live class. So here it is told that a thin uniform rectangular plate of mass 2 kg, it is having mass 2 kg, is placed in the xy plane. The moment of inertia about the x-axis, ix, that is given as 0.2 kg meter square, and the moment of inertia about the y-axis, so where x and y-axis are lying along the plane of the rectangular plate, so iy, that is given as 0.3 kg meter square. The radius of gyration, which is k, that of the plate about the axis passing through the point O and perpendicular to the plane of the plate is how much? So it means that radius of gyration of the plate about z, so k about z, that we have to find. So it means that if iz, it means the moment of inertia about the z-axis. Since z-axis is perpendicular to the plane of the plate, So now if iz, which is the moment of inertia about the z-axis for this rectangular plate, that is equal to mk square, mass of the plate is 2 kg, then we have to find that k, which is the radius of gyration about the z-axis. Radius of gyration of this plate, about z-axis. So that we need to find. So now therefore iz, we know that iz will be equal to ix plus iy. How? By using the perpendicular axis theorem on the moment of inertia. Is the perpendicular axis theorem on the moment of inertia. Okay. So moment of inertia. Okay. So then therefore iz will be equal to ix, that is 0.2 plus 0.3, that is 0.5 kg meter square. So now we have to find k square. So k square is iz by m. So that will be 0.5 by 2. So that is half by 1 by 2, that is So this we can write 0.25. 0.25 meter square actually. This will be. So therefore K will be equal to 0.5 meter. 0.5 meter, or you can say 50 centimeter. So therefore the required radius of gyration is 50 centimeter about the z-axis. So option C is the correct answer. So hope you have understood the solutions of all these questions, and if you find difficulty in understanding any of the steps of the solutions or any other doubts if you are having, then please write us in the comments section. And any other chapter if you feel that is very difficult for you, then also please mention the name of that chapter in the comments, and please solve the homeworks which will be uploaded in the Sapience education application. So thank you everyone. Bye.